Hello students, today I will tell you about the excitation energy of hydrogen atom. Before that, I told you about the excitation energy of the energy states. So except to the ground state, now all the energy states are the excited energy states. But here when we have to find the excitation energy of the atom, then this is always a difference of the energy states between the ground state and some excited energy state. So the excitation energy is always calculated with respect to the ground state. The excitation energy of atom is calculated with respect to ground state of the atom. Ground state of the atom is where the unpaired electron is found. Since hydrogen atom is a single electron system, so it has only one electron and it is always found in the ground state. Energy of nth level En equal to minus 13.6 upon n square z square electron volt. And we are taking the hydrogen atom. So for hydrogen atom, z equal to 1. Therefore, this En equal to minus 13.6 upon n square electron volt. This is the energy of the nth energy state of the hydrogen atom. So in ground state, n equal to 1, so this E1 equal to minus 13.6 electron volt. Now then to find the first excitation energy, second excitation energy, third excitation energy and so on. First excitation energy means the electron is to be excited from ground state to the second energy state. The second excitation energy means the electron is to be excited from ground state to the third energy state and so on. Excitation energy. Ex, this is found with respect to the, so this is now your minus 13.6 upon n2 square minus 13.6. So much. This is in ground state. So this Ex equal to 13.6 minus 13.6 upon n2 square, so much electron volt, where or better to have this N2 equal to 2, 3, 4, 5 and so on. Because first we have calculated the energy for the ground state. That is now N equal to 1 here. So now for first excitation energy, first excitation energy of hydrogen atom. Now this EX1 is equal to 13.6 minus 13.6 upon 4. So much electron volt. Now here we will put N equal to 2. N equal to 2. So this is equal to 13.6 minus, this is now your 3.4. So much electron volt. And this is equal to your 10.2 electron volt. This is EX1. So now how to visualize to this one, that this is now suppose N equal to 1. This is now first ground state. This is now N equal to 2. So now electron is being excited like this. From ground state to second energy state. That is now first excitation energy. Now second excitation energy. Of hydrogen atom. Now this EX2, this is equal to 13.6 minus 13.6 upon, now this is 9 electron volt. Here N2 is equal to 3. N2 equal to 3. So now you can have to this one 13.6 minus, this is now 1.51 446.51. So much electron volt, and this EX2 is equal to, this is now your 51, so this is now 0.09 and this is now your 12. So much electron volt. So here, if we want to show this in the diagram, then we can have this is now N equal to 1, this is N equal to 2, this is N equal to 3. This means that the electron is being excited from this to this one, from N equal to 1 to N equal to 3. So this is the second excitation energy. Now third excitation energy. Of hydrogen atom. Now here this EX2, EX3. This is equal to 13.6 minus 13.6 upon, now this is now 16. So much electron volt. Here N2 is equal to 4. So now this is equal to 13.6 minus, this is now 0.85. So much electron volt. And this is now your This is now your 5, 15, so this is now your 7, so this is now your 12. So much electron volt. This is EX3. EX3. Right, so then we can visualize to this one like this one. This is n equal to 1, this is n equal to 2, this is n equal to 3, and this is now n equal to 4. So electron is going from this state to this one, from first to fourth. So this is now third excitation energy, and similarly we can calculate the excitation energy, the third, now fourth, then fifth, then sixth, and so on. Thus, fourth, fifth, sixth, etc. Excitation energy of hydrogen atom can be calculated. So now if we want to show this in the diagram, then how to find to this one? Now in the diagram we can show to like this. This is now nucleus. This is now first energy state. This is not like this. Here this is n equal to 1, n equal to 2, n equal to 3, n equal to 4. So now from this we are having to this energy state, this energy state, this energy state. So this is EX1. This is EX1. This is EX2. This is EX3. EX3. So we can see that as the excitation energy, as the excitation energy increases, the number of energy states also increases. Thus, excitation energy increases as the energy states become higher and higher. Higher and higher. So you can see that this is now first was your 10 point something, second was now this different to this one, and third is so much. So this energy is increasing. This excitation energy is being increased as the energy states become higher and higher. So this is what the excitation energy of the hydrogen atom. So whenever we have to find the excitation energy of the atom, then this you always calculate with respect to the ground state. So this is the difference of the two energy states between which the electron is to be excited. So now this is all about the excitation energy of the atom, and whenever we have to find the excitation energy of the energy state, that is a different one. In energy state, whatever you are finding the energy of the energy state, that is the excitation energy of the state, not the excitation energy of the atom. And to excite the electron, always the energy is supplied from the outside source. So the electron absorbs the energy in the form of discrete energy, and then it excited to the high energy state, and that absorbed energy is always equal to the difference or to this excitation energy of the electron. So this is the difference of the two energy states, so the ground energy state and the excited energy state. So that we find the excitation energy of the hydrogen atom. So thank you very much.